All right. Excuse me. I guess I didn't see that this is recording already. Um, all right, let's get right in here. Section 3.1, talking about solving quadratic equations. So last time we were talking about uh, graphing quadratic equations. Now we're actually going to be talking about this over here, the way we solve them. So a couple ways we could do this. First of all, we're going to start by factoring, which is applying the zero product property. And now a quick thing about what the zero product property is. That's just saying any number, if you have two numbers, x times y equals 0, either one of those or both of those has to equal 0. So if x equals 0, 0 times y would equal 0, right? Or y could be 0. X times 0 is still equal to 0, or they both could be 0. 0 times 0 equals 0. So it's one or both variables would have to equal 0. So let's take a look and see how that works. So solving these by factoring. Factoring is going to be the opposite of multiplying, basically. So first step here is we're going to be setting the equation equal to 0. So set the equation equal to 0. Okay, so let's start with number 4. So that means I got to move the 48 over. So I'll subtract 48 on both sides. And I've got x squared plus 2x minus 48 is equal to 0. Step 2 is going to be to factor using your different methods. Factor. So the first one for number 4, as far as how the factoring of this works, we're going to be using what we call the magic x. So the magic x works like this. I'm finding two numbers that add up to b, which in this case is 2, and multiply to c, which is negative 48. So two numbers that multiply to 2 or add to 2 and multiply to negative 48. Playing around with some of these, I'm thinking, okay, maybe 6 times 8 is 48. I need that to be a positive 2, so I'll say negative 6 times 8. Because when I add those together, they add up to positive 2, and multiplying makes negative 48. So we end up with x minus 6 and x plus 8. This is how we write it. We end up splitting this apart. So x minus 6 and x plus 8 equals 0. So then solving this, now we're going to apply step 3. That's our factoring process. Now we're going to be apply zero product property. And step 4 is going to be solve. So setting these equal means one or both of these groupings is going to have to equal 0. So we're going to say x minus 6 equals 0 first, and x plus 8 is equal to 0. So when I add 6 on both sides to this equation, I get x is equal to 6. And when I subtract 8 on this side, I get x is equal to negative 8. So those are my two solutions to my problem here. So let's try number 5, because number 5 is just a little bit different. Well, we have to start by setting this equal to 0, so add 3 on both sides. So 4x squared minus 13x plus 3 is equal to 0. And now we're going to apply our methods of factoring. This is a little different because the a term here, is not equal to 1. It's got a number there. So the magic x looks a little different. We're going to find two numbers still that add up to b. So in this case, negative 13. But for the bottom, it needs to multiply to a times c, which in this case is 4 times 3, which is 12, the 4 and the 3. I need to find two numbers that multiply to 12, and that's negative 13. Although that it has to be 12 and 1 would be 13. But we're going to do negative 12 and negative 1 to make it so they add to negative 13. So we solve this. We get 4x squared, or when we now do this, 4x squared, we're just going to split the x into negative 12x minus 1x plus 3 is equal to 0. I haven't even got to the factor part yet. I'm still kind of setting this up for factoring, because now what I could do is group these in factor. So I'll factor out the greatest common factor of my first pair here, which is 4x, which leaves me with x minus 3. I'm going to factor out a negative 1 because I can't have my leading coefficient as a negative there. So factor out negative 1, x minus 3, which equals 0. Then I end up with 4x minus 1 and x minus 3 as my factoring. And then I could solve just like I did in the previous equation there, or number 4. Interesting numbering we had. So I'll say 4x minus 1 equal, oh, we can't see that. Let's try. 4x minus 1 equals 0. There we go. X minus 3 equals 0. So I get x is equal to 3. That's good. 4x is equal to 1, and then divide both sides by 4. And x is equal to 1/4, and x is equal to 3. Two solutions. We end up with two solutions to these. Okay. Same idea here for my next problem. A monthly skateboard magazine has 50,000 subscribers when it charges $12 per annual subscription. For each $1 price increase, the magazine loses about $2,500 or 2,500 subscribers. How much should the magazine charge to maximize annual revenue? What is the maximum annual revenue? So we'll start by saying, okay, our total revenue, I'll use words first, is going to be equal to the number of subscriptions, subscriptions times how much it costs. Okay, well, the number of subscriptions is going to be represented by that 50,000 subscribers minus $2,500 per increase in price. So that $50,000 minus 2,500 X per that increase in price. And now, oops, I don't know why I put money sign. Now to talk about the money, it's $12 plus every extra dollar that you add. Well, R of X, the revenue of, and this as a function. So that could solve. And we could do this a couple ways. I'm going to set this, well, that's just what the equation is, right? How much should the magazine charge to maximize annual revenue? So we want to find the maximum of this, which means we want to find the vertex. So first, we should probably make this into a quadratic equation. This is going to be applying what we did in the last section, actually. We haven't exactly got here. Well, actually, let's do it this way. Let's not multiply. Let's just go from here. Let's find the x-intercepts or the zeros of this graph. So we'll set this equal to 0. So 0 is equal to 50,000 minus 2,500x. Well, plus x. So we'll set each individual one equal to 0. So 50,000, 0 product property, right? Set the equal to 0. Now we're in step 2, which is factor. So minus 2,500x equals 0. And 0 is equal to 12 plus x. So I got on the one hand, negative 12 is equal to x. So there's one of my solutions. Let's subtract 50,000 on both sides. So we got negative 50,000. It's equal to negative 2,500x, which means x is going to be equal to, it's like 20. So there are my two solutions. And those are also my x-intercepts. I'm going to clear some space over here. So if I have a quick sketch of a graph, there's my coordinate plane. I would have negative 12, 0, and then I'd have 20, 0. My graph would look something like this. So it wants the maximum. So I got to find the maximum, which is the y value for the x, for the vertex, basically. So now I have to find the vertex, but it's just basically a function, quadratic function that we have in intercept form, which we talked about graphing already in the previous section. So what we'll do is we'll follow the same process we did before, where we'll take to find the x, so we have our vertex. Let's do it this way. X and a y. So to find the x coordinate, we'll take negative 12. We'll add them together in the middle. Okay, which gives me 8 over 2, which is 4. Great. So that's the x coordinate of my vertex. Now I have to find the y. So I'm just going to take that and plug it into my function all over the place with my colors right now for x. So let's move over to here. All over the place. I apologize that there's not a lot of space on your notes for this. Okay. Okay. All right, cool. We'll do pink. So we're going to say, okay, R of 4 is going to be equal to 50,000 minus $2,500 times 4. Can I write out there? I can. And then that's going to all be times by 12 plus 4. So our maximum is going to come with a $4 increase, actually. So let's plug in the calculator. Let's do 50,000 minus 2,500 times 4. So 40,000 times 16, which means my maximum here is going to be $640,000. So that's my maximum revenue I can make, and that's from adding $4. So actually, the best price I want to maximize my revenue of this magazine is going to be adding it by $4, which will be $16 total. So it's okay. You got to lose some subscribers to make some money, I guess, which is kind of the nature of business. All right, let's continue on into the last part here, which is going to be, where is it? Solving these quadratics using a method called square roots. There. Snip that, snip this. Boom. Cool. So the method of square roots is going to be very much like solving the problems like we've been doing, except at the end to solve for x, you'll end up taking the square root. Still doing PEMDAS in reverse order. We can still think of it as that. So PEMDAS. So reverse order solving these equations. We'll start by, is there any addition or subtraction to take care of? We'll subtract 14 on both sides. So I get 2x squared is equal to 70 minus 14. I should be able to do that in my head. I can't. 56. I shouldn't say I can't. I prefer to do it in the calculator. Okay, now I can do any multiplication or division because those are done. Divide by 2. X squared is equal to half of 56, which is 28. Done. And now I can address the exponents. There's x squared. The opposite of squaring something is to square root. So x is going to be equal to, we need to be very careful here. When we take the square root of this, we can simplify the square roots. The square root of 28 simplifies. So what we'll do is we'll say, okay, 7 and 4, 2 and 2. We're breaking this down into the prime factorization. I have a pair of 2's. So that simplifies to be plus or minus. Whenever we take the square root of something, we do plus or minus, because 2 squared is equal to 4, but negative 2 squared is still equal to positive 4. So the plus or minus of 2 radical 7. We can never forget that plus or minus. So there we go for the first problem. I'm going to do the next 2 and have you guys try the bottom 2 on your own. Okay, so let's go from here. Same idea with the PEMDAS. So this is kind of a good example to see what happens. Start with any addition or subtraction, don't have it. Any multiplication or division, I do. I'm going to multiply this by 4/3 because those will cancel. So I end up with x plus 1 squared is equal to 10 times 4, which is 40. I don't think that divides evenly. Nope. So we just end up with 40 over 3. Okay. Take the square root of both sides. X plus 1 is equal to the square root of 40 over the square root of 3. Interesting thing that happens here is we don't want that square root of 3. So we're going to rationalize this by multiplying by the square root of 3 or the square root of 3. So x plus 1, again, not a lot of space, but it's probably just the way that I'm writing this, which is the square root of 40 times 3, which is 120, all over 3. And then to finish it off, I'm going to subtract 1 on both sides. Those will go away. But the problem is I need to simplify that 120. So let's find out how we can simplify that. Ooh, can't really see that. The square root of 120. So you have 10 and 12, 5 and 2, 4 and 3, 2 and 2. Well, I only have a pair of 2's. So it looks like I got 2 radical 5 times 2 times 3 on the inside there still. So it's going to be 2 radical 30. Interesting how that works out. So our final answer gives us 2 radical 30 all over 3 minus 1. They're not always perfect answers, especially at this stage of our mathematical journey. Last one I'm going to do before you guys try some. I guess that's not number anymore, but number 3. Let's use blue. I haven't used blue yet. So we'll start by subtract. Actually, you know what? At this point, I'd like you to pause the video and try the rest of these problems on your own. So pause the video now, try the rest of these 4 questions on your own, and then resume when you're ready to go. Okay, let's start fresh here. We'll start by subtracting 25 on both sides. So 3x squared is equal to negative 416. I'm never opposed to you guys using a calculator. Oops, negative 416 minus 25. It's a good tool to know how to use. Negative 441. Divide both sides by 3. Oh, it's so nice this time. Negative 147. Take the square root. So x is then equal to plus or minus. Don't forget plus or minus. Well, that actually simplifies there. Well, when you take the square root of something and it's a negative, it's not able to happen. There's actually no solution for this, because think about it. If 2 times 2 is positive 4, but then negative 2 times negative 2 is 4, we never actually get a negative. So when we have a negative under the radical sign or the square root sign like that, it means we don't end up with an answer. Okay, which actually, let's just do this one while we're at it, because the same thing kind of happens. So I was supposed to do that one first, but that's okay. So x squared is equal to negative 121. Take the square root on both sides. And again, can't take the square root of negative. So we got no solution. The bottom left of this grid, start by dividing both sides by 2. X minus 5 squared is equal to 40. Take the square root of that. Get x minus 5 is equal to plus or minus the square root of 40. See if that simplifies. Well, 10 and 4, 5 and 2, 2 and 2. I got a pair. So it's going to be 2. Bring that out. Whatever's left, leave it inside. 5 times 2, which is 10. And then add 5 to both sides. So x is equal to 5 plus or minus 2 times the square root of 10. And then finally, our last question here. Find the zeros. So first step, set it equal to 0. And solve. So divide by 7 or subtract 70 on both sides. Negative 70 is equal to 7x squared. Divide by 7. X squared is equal to negative 10. Take the square root. Can't do the square root still of a negative number. So we get another no solution. So there we go, talking about factoring to solve these quadratic equations. The next 2 sections are the exact same kind of thing, except we're going to be using different methods of factoring or different methods of solving equations to do that, because not everything can factor so nicely like this, and you'll see it in the next section. So I will see you in lesson 2.